Alright, so in a previous lesson we learned the product rule, how we take the derivative of two things that are being multiplied together. Here we're going to learn the quotient rule. So if you have two functions that are divided by one another, so if you want the derivative of f of x over g of x, we just use this very simple formula. Really straightforward. The reality is this looks really scary. I color-coded it just so that you wouldn't run away. Right? What you do is you leave the bottom function alone, multiply by the derivative of the top function, then minus, leave the top function alone, multiply by the derivative of the bottom function, and then divide by the bottom function squared. Memorizing that is challenging. So fortunately, there's like a little rhyme that you can use for it. And so here's our little rhyme. And I put little music notes so that you know that it's a rhyme. So check this out, right? So it's low d high, so that means use the low function, d high, derivative of the high function, minus high d low. So you leave the high function alone and do the derivative of the low function. Square the bottom, and away we go. And the key here, doing some meta rhyming here, that low rhymes with go. And so it reminds you that it's supposed to work, because you see low d high minus high d low, square the bottom, and away we go. It has this nice rhythmic sense to it, and we can remember low d high minus high d low, square the bottom, and away we go. You can do that, right? So that's how we use the quotient rule. I'll be totally honest, to this day, when I do the quotient rule, that rhyme always happens in my head. I'm not saying it out loud, but it's going on in my head. Actually, I do say it out loud sometimes. So, my first example here is for us to think about why we don't need to use the quotient rule for this problem. Because, to be honest, the quotient rule is a pain, right? We really want to avoid using it whenever we can. So why don't I need the quotient rule in this problem? And the answer is, in my opinion, this is just an example of the constant multiple rule. I could write this as 1/5 times secant x, and to do the derivative of that, I just leave the 1/5 alone and multiply by the derivative of secant x, which you guys are starting to memorize now. The derivative of secant x is secant x tangent x, and there it is. Now, if you could use the quotient rule in this thing, it'll work. Like, you'll eventually simplify down to this answer, but you don't have to. And so please understand, we really only need to use the quotient rule when there are both variable expressions. So here's a better example of that. So I want to find h prime of x given this function. So if you're feeling up to it, use the quotient rule on your own. Otherwise, watch me do it, and you can do the next one on your own. So here we go, with magic rhyme power and everything. H prime of x, the derivative of this, will be, and I'll try and color code this as we did before, low, oops, not 5x, I already made a mess of this. Let's see here, so low d high minus high d low, square the bottom, and away we go, or come at me bro, or row row row, or hi ho, it's off to work we go. As long as it rhymes with low, I'm happy. So now I'll go through and I'll simplify this thing. Okay? So I'm going to distribute the 3 and end up getting 15 minus 6x. Now this next part, things get a little bit funky, and I would recommend sort of rearranging this so you can see it better. This is basically, like, if you think about what's happening up here, this is minus negative 2 times 3x minus 1. Okay, I think it's easier if you have got a constant, move that to the front. Then we're going to see that this is plus a positive 2 being distributed, and it'll be a lot easier for us to recognize that's going to be plus 6x minus 2. Okay, so again, my recommendation there, if you've got a constant like this, move it to the front, combine that with a negative, then distribute that through. On the bottom, I just have 5 minus 2x squared. I'm actually not going to expand that. I'm not going to work with that. I'm just going to leave it like it is. H prime of x, if we simplify this, we're going to end up with 13, minus 6x plus 6x. Those will add up to 0. So I get 13 over 5 minus 2x squared, and that's it. That's my derivative, right? That is h prime of x. So one more example of a quotient rule for us. This one isn't going to be particularly beautiful, but trig functions are often involved in quotient rules, so it's valuable for us to have some experience with it. If you haven't done so on any previous problems, I really want you to pause the video and try this one on your own. Make sure you're getting a chance to use that rhyme and use it effectively. So I am supposed to have low d high. Now the derivative of cotangent is negative cosecant squared x, low d high, minus high d low, square the bottom. So squaring the bottom is going to give me x squared squared, and away we go. So now that I have this thing, I can go back through and try to simplify a little bit. In particular, move negatives around, get rid of parentheses when unnecessary. I'm going to have negative x squared cosecant squared x minus 2x cotangent x all over x to the fourth. The only other thing I can see to do here is that you'll notice that all three of these terms, this one and this one and this one, all have at least one factor of x. So that means I could divide out an x from here, and from here, and get a slightly simpler answer. Negative x cosecant squared x minus 2 cotangent x all over x cubed. And there it is. That's my derivative. That's the best I can do. Keep in mind, you can use the quotient rule to find the equation of tangent lines. You can do anything you would have done with a derivative, you can do using the quotient rule.